All right, let's talk Kubernetes. It's an absolutely incredible tool, right? But it's also a minefield of common mistakes, the kind of mistakes that can silently take down your entire production environment. So today, we're going to dig into the top 10 pitfalls and, most importantly, show you exactly how to fix them. So let me ask you this directly. Is your cluster a ticking time bomb? The really scary part is it might be, and you might not even know it. The issues we're about to cover are such common traps that even really experienced developers fall into them all the time. So this isn't about pointing fingers, it's about finding and disarming these little bombs before they have a chance to go off. So here's our game plan for today. We're going to start with foundational flaws, then move into critical security gaps. After that, we'll tackle resiliency and scaling traps, and then the big one, the danger of flying blind in production. And to wrap it all up, we'll finish with a quick health check you can run on your own cluster. Let's get into it. First up, let's set the stage and talk about what I like to call the silent killers. These are the small, seemingly harmless mistakes that can lead to some truly catastrophic failures down the line. And here's the thing, nobody is immune to these. I've seen these exact problems in clusters at tiny startups and at massive, massive companies. They are the silent killers because they don't make a lot of noise until they cause a massive cascading failure, usually at the worst possible time. All right, on to our first real category, foundational flaws. Getting these wrong is kind of like building a skyscraper on sand. Sooner or later, it's all going to come tumbling down. Mistake number 1, deploying your pods without any resource limits. This is a classic, and it's a complete recipe for disaster. It creates what we call the noisy neighbor problem. One application goes haywire, eats up all the CPU and memory, and starves every other application on that node. The fix, thankfully, is right there in your YAML. You just have to define requests and limits. It's you telling Kubernetes exactly what the app needs and where to draw the line, preventing one bad pod from trashing the whole neighborhood. Next up, and oh man, this is a big one, using the latest tag in production. Just don't do it. Imagine a recipe that just says add flour. It's completely unpredictable, right? The latest tag can change under your feet at any time, which leads to totally inconsistent deployments and makes rolling back a change a complete nightmare. The only sane way to do this is to use specific version tags, like you see here. It makes your builds predictable and reliable every single time. And then we have the default namespace, which I like to call the junk drawer of your cluster. When you just dump everything in one place, managing permissions or RBAC becomes an impossible mess. The solution is to have a clear namespace strategy. Separate your workloads into logical buckets like dev, staging, and production. This creates clear boundaries and gives you much, much finer control over your cluster. Okay, so our foundation is stable. That's a great start. Now it's time to lock all the doors and windows by tackling some critical security gaps. Running your containers as the root user, this is like handing an intruder the master key to your entire house. If your application gets compromised, the attacker has root inside the container, and from there, it's often a short hop to taking over the entire node. What's amazing, though, is how simple the fix is. You just add a security context to your pod configuration and tell it to run as a non-root user. It is a tiny change that gives you a massive security win. This next one is a classic, storing your secrets in plain text. Putting a database password directly into a config map or an environment variable, that's like writing your password on a sticky note and putting it on your monitor for everyone to see. The proper way to handle this is to use native Kubernetes secrets. This keeps all your sensitive data separate and secure, and very importantly, out of your version control history. By default, a Kubernetes cluster is like a house with no internal walls. Every single pod can talk to every other pod. If one of them gets compromised, an attacker can just move laterally across your entire network. The solution is to build those walls using network policies. You can create a default deny rule and then explicitly allow only the traffic you absolutely need, like letting your front end talk to your back end and nothing else. Okay, so your cluster is secure, fantastic, but can it survive a failure? Can it actually handle a sudden spike in traffic? Let's look at some of the common traps that can really impact the resilience and scaling of your applications. If you deploy without health checks, Kubernetes is basically flying blind. It has no idea if your app is working or not. It might just keep sending traffic to a pod that's completely broken. The fix is to implement probes. A liveness probe asks, "Are you alive?" And if the answer is no, Kubernetes restarts the container. A readiness probe asks, "Are you ready to serve traffic?" And if not, Kubernetes stops sending it requests until it's ready.
So, what happens during routine maintenance, like a node upgrade? Well, without any protection, Kubernetes might decide to kill all replicas of your critical painted service at the same time. This is what we call self-inflicted downtime. A pod disruption budget, or PDB, is your safety net. It's a simple rule you give the cluster that says, hey, no matter what you're doing, always keep at least 2 of these pods running. It's a lifesaver.
Having a fixed number of replicas for your app means you're almost always wrong. During quiet times, you're just wasting money on idle pods, and during a traffic spike, you don't have enough pods, and performance just tanks. The really elegant solution here is the horizontal pod autoscaler, or HPA. You define a minimum and a maximum, set a target like 70% CPU utilization, and Kubernetes automatically scales your application up and down for you. It's way more efficient and cost-effective. Okay, so your cluster is stable, it's secure, and it's scalable. That's pretty good. But all of that is kind of useless if you can't actually see what's happening inside. This brings us to our final and absolutely critical mistake: flying blind. Running in production without proper logging and monitoring is like driving a car at night with no dashboard and no headlights. You are just waiting for a crash, and when something inevitably breaks, you'll have absolutely no idea why. That's why a full observability stack is completely non-negotiable. You need centralized logs, you need metrics collection with something like Prometheus, and you need to instrument your applications so they tell you what's going on. Okay, we've covered a lot of theory. Now let's turn all of that knowledge into action. Here is a quick health check that you can run on your cluster literally right now. You can start fixing your cluster right now. This slide has 3 one-liner commands to find some of the biggest offenders we just talked about: pods without resource limits, pods running as root, and deployments that don't have an autoscaler. I really encourage you, pause this, copy these commands, and run them in your own environment. I think you might be surprised at what you find. And that's our list. Making these mistakes is just part of the learning curve with a complex system like Kubernetes. The key is to find them, fix them, and build more resilient systems because of them. So I'll just leave you with this question. What bombs have you had to defuse in your own clusters? Share your experiences, because that's really how we all get better at building things that don't break in the middle of the night.